very first session at the Industrial Vision Days 2021. So the first session is all about 3D. And I'm excited to have already 3 speakers here with me. And I would just say, Thomas from Photonfocus, go ahead and start with your presentation. So please.
Thank you very much for the invitation, and hello all together. It's my pleasure to have the first speech of the Vision 2021. And I'd like to tell you a bit about our 3D cameras and what you can do with it, and give you some hints what you can do, what kind of use cases you can probably solve, which you was not thinking about. Oops, doesn't work. No, it works. So, just an introduction of myself. I'm from Photonfocus, and I'm the new field application engineer. I'm responsible for all the solutions of the customers. And in this case, I'm here to show you what new things we have done in the time of the pandemic. We are still working on new things. So I'd like to show you Photonfocus at a glance, just a short introduction of it, give you some of our ideas about behind our modular camera concept, as well as just a short introduction of 3D laser triangulation, what it is in basic, and then also the thinking of the wavelength for these use cases, what they can bring you in your application, in your solutions, and certainly some use cases. First of all, who is Photonfocus? I hope many of you already know Photonfocus, because we are on the market since 20 years now as a spin-off of the ETH Zurich. So we have the pleasure that we have great people in-house doing sensor development. So we are doing the development of our own sensors, which enables us to bring cameras also to solutions where standard cameras and sensors are not useful for. So the main product lines, as you can read here, we have certainly the 2D applications, not only in the visible spectrum, but also in the ultraviolet and short-wave infrared, and also hyperspectral, which gives you the possibility to acquire images from UV up to infrared. Also, we have 3D application, which means that you can use the camera with an onboard application, our onboard IP core, so the camera itself can do the 3D recognition and gives you as a result directly the 3D information, so that the host PC doesn't have to do the job to directly generate the point cloud or whatever. And certainly we have the CMOS sensors in special, which we are developing by ourselves. So just to give you an overview, all of our cameras are based on the modular camera setup. We have a concept designed which is mainly built of 4 different parts. One are the imagers, so the image sensors, and we have plenty of them, and we can easily do adaptation to your needs. So if there comes up a new use case which needs a special sensor, and either we have or the market gives us a special sensor which fits perfectly to your needs, we are able to implement it, and we just have to implement it on the imager size and not a complete new camera. The next is we have the processors behind. So we have the imagers giving us the image data. we have a processor board behind, mostly based on FPGAs, which can do anything with the image data. So, for example, doing the 3D, which we are talking about, but also some kind of pre-processing, some kind of image compression, for example, to have a bigger, higher frame rate, double rate, and so on. And many more things. Also, we can do it very easily because also internally the FPGA is on our side internally split it in different modules. So we have different modules on stock and we can bring it all together to a new processor board. It's the same hardware, but another algorithms on it matching to the new needs. And certainly we have interfaces. So all the processed or non-processed data have to be transferred from the camera to the host PC. And also on this side, we are very open what we can do. We are starting certainly by the most common interface, which is 1 gigabit Ethernet. We have 10 gigabit Ethernet. We will have Coax Express, Camera Link, and so on. Maybe also in OEM things going to LVDS directly. So you can put it directly on your PCB where you complete PCs running on, for example. And certainly we have the mechanics, so either you are using it as a stack of PCBs or you're going to have a housing around that and put all the stuff together to the housing. So taking this modular concept, all our standard cameras are based on this system. So either it's the classic one, the old ones, the compact, the spectral, high-speed, high-res 3D, all those cameras are based on our modular concept, which directly shows you how easy it is for us, and so also easy for you, to get a new camera right out of some kind of the bricks you put in together as you did it in your childhood, maybe. And as soon as we come to the state that all the pre-designed cameras, so our standard models, are not matching to your needs, we can sit together, speak about your application, your needs, and we can go to the custom design. So we sit together, we think about what kind of images we need, what kind of processors, what kind of algorithms in the processor board we need, and what kind of interfaces you need. We can bring it together in a very short development time because we have such kind of a stock of each module. We can bring it together, make a new camera tailored directly for your needs. And yes, certainly you can use it directly on your side. And exactly in the custom design, that's also my part as a field application engineer. I'm glad if you come to us, speak to me directly, and we can figure out what kind of camera, what kind of solution could be the best for you. As I said, just for those who may not know the 3D laser triangulation algorithm right now, I think most of you already knows this. So just in short, you have a laser projecting a line on the surface of the object you want to inspect. You have a camera on the other side which looks exactly on this kind of line. Now we know the angles between the laser and the camera, and because we know and have calibrated the complete application, we can calculate the position of one point back in height. It's a very easy thing. Just looking at the laser line, let the camera find the line, and let the camera also calculate the height of each point which was found. This is in theory, but in real life, those images look sometimes completely different. So we have to deal with many different, let's say, distortions, error, however you want to tell it. So one thing can be reflections. So reflections coming from anywhere. So you have a surface like a glass, like metal or something else. The laser line can be reflected in any way and come into the image again, and maybe the algorithm would recognize that as a point of the laser line, but it's wrong because it's just a reflection. The same can happen with mirroring, which we can see on the upper image. On the laser line itself is the yellow line, and the mirroring and some of the reflections are the blue ones. So it's just because it's a metal surface and the one laser line is mirrored to the other side. So the algorithm may not know what is the right laser line or right point to detect. Certainly we have to deal with transparency. So taking a glass, for example, most of the visible light will go through the glass and you won't see the line directly. What we can see below, it's the black part in between. It's glass. The laser line is gone, so we are not able to find the laser line anymore. Absorption, certainly everybody knows. Take a red laser line on a green surface, you won't see the laser line anymore because it's directly absorbed by the green surface. And with all these things we have to deal. And now we come to the state, what can we do to get to better results? The better results in one point can be the algorithm, which is used to find the right position of one laser line. So the most common one is the center of gravity. So just taking, in German it's the Schwerpunkt of it. Or you can go to the peak, looking at the contour structure of the laser line, and you can find the peak. And both of these algorithms are available on our cameras. So for easy one, which goes very fast, it's the center of gravity, or you can do the very, the more processing one, it's the FIR from us. Certainly. We can do one or multi-peak things. So looking at the two laser lines, maybe it's a reflection or not, you have two peaks. And you can figure out what's your right peak. You know, the one peak is above and the right peak is below. You can filter it. You get not only the position where the point is, but you can also get the width of the laser line in the found point. So you can figure out if the width of the line is too big, it's maybe a distortion or something else. Also, you can use multiple arrow eyes. So just not using the complete image, just looking at a certain part of the image where you expect to have the laser line. All others would be a reflection or anything else. And something special we have, which is not very common on the market, we have moving arrow eyes. So once you have set up your laser line, the algorithm can follow the line from one image to the other, still every time finding the laser line. The next thing is, which I also mentioned, is the wavelength of the light. You probably know this. We have in the middle the visible light spectrum we can see with our eyes. We have the ultraviolet on the other side going down. It's something which it's not good for our skin. And also the infrared ones. So in this case, we can think about what can the wavelengths be good for us for improving the results we can get. So in this case, we have to figure out how different materials interact with the wavelengths. Not all you can see with your eyes is directly or exactly can be seen also with other wavelengths. So the one which is probably known is the above one from the money. you're using ultraviolet and you get a response in a visible one, so mostly it's the yellow, or, which is not very commonly known, below sugar and salt. If you have a look at sugar and salt directly in a visible light, it looks completely the same. It's both white. But taking a short-wave infrared camera, you can define what is sugar and what is salt, because the sugar directly, completely absorbs the short-wave infrared. And this thing you can use for your application. So you can think about what kind of material do I have, what interaction has my material with different wavelengths, and choose the right wavelength to have the best solution then. One use case, for example, is 3D on glass surfaces, a very, very difficult one. So most glasses on the above you can see with visible light, you cannot see any laser line correctly anymore. Taking a UV laser at 375 nanometers, you can directly see the laser line because the glass reflects UV light and it's not transparent for the UV. So glass inspection 3D with a laser line is possible if you choose the right settings. Another thing which could happen is that you want to inspect a surface below an anodized surface. So the anodized surface in visible light is completely dark, so we cannot see through. Take near infrared, you can look through most of the anodized surfaces, and you are then possible to inspect your product also after it was anodized. Just to give you an impression what is possible to do. So, to get to the end, nearly in time, just to resume, certainly we have a modular concept. You can come to us, we can find out what is the right camera for you. Also, we can help you to find out what kind of wavelengths could be really suitable for your application, maybe which wasn't able to be solved in the past because of the algorithms or because of the wavelengths, because it cannot be seen with the standard wavelengths. And altogether, I would like to talk to you not only at our booth. It would be great if you could meet us there, but also talk to us, talk to me, just call me, and we can talk together about your solution, and hopefully we can find the best solution which could be achieved on your side. Thank you very much. And yes, 40 seconds.
Made it. Very punctual. Thank you, Thomas.
You're welcome.
Thomas Wimmer, 3D cameras for laser triangulation. Thank you for your presentation.
Thanks also.
I have not received any questions to you, so I guess people will ask questions at your booth. Just a comment. You'll find a QR code on the tables. Yeah, you're welcome to check in and ask your questions, so we will see it. And those who are at home participating online, please feel free to also ask your questions, so we can cover it here. So, Thomas, thank you.
Thanks also. Have a good time.